x graph.
Okay.
The quadratic function is x squared minus x minus 6.
Couple ways to do this. One is we can try to put it into vertex format, which requires completing the square. The other way to do it is to factor it and put it into x-intercept format. Notice that this factors quite nicely into what?
X minus 3x plus 2.
Therefore, the zeros of this quadratic are where?
3 and negative 2.
So, is it pointing upwards or downwards?
The graph's pointing up.
Okay. So the only point we really need, since we know it goes through there and there, if we can find the vertex, we'll be able to graph it. So where's the vertex? What's the definition for vertex of a quadratic?
Like,
We should say the vertex x-coordinate.
isn't it like k or something? Is that what you're asking for?
Minus b over 2a.
Oh, okay. Not squared?
No, just minus b over 2a. Notice that that's the first half of the quadratic formula. Quadratic formula is minus b plus or minus b squared minus 4ac all over 2a. This part of it right there is just the vertex. Well, like I said, it's the x-coordinate of the vertex. So it's pretty easy to figure that. So what does that equal to? What's b?
1 over 1/2. Oh, it's 1. Negative 1.
Okay, so the vertex x-coordinate is 1/2.
Yeah, 1/2.
Because it's negative negative, so it's 1 over 2. And so what is the vertex y-coordinate, which is the last thing we need?
Isn't this one we put it into standard form and it's like the last?
No, just substitute it into the original function.
You plug 1/2 in for x.
Exactly, and then that'll give you the y-coordinate.
What's 1/2 squared?
1/4
Okay.
minus 1/2 minus 6 gives us minus 6 and 1/4. So now we have our vertex, which is, we'll call this 1/2 down here minus, so if I label that point, it's 1/2 comma minus 6 and 1/4. And now that's everything we need to graph that.
Okay, that makes sense.
Okay. Now, that was a fairly complicated thing to have to do, all of that. So maybe it's worth taking a look at putting it into vertex format in the first place. I don't know. What do you think?
I forgot. Also, it says we have to put it into standard form. Is that ax squared plus bx plus c or something? Is that standard too?
Yeah. Okay. So if I put it into standard form here, I just want to get everything on one side. Standard form is ax squared plus bx plus c equals 0, or standard form ax squared plus, standard form is ax plus by, correct?
I don't remember. I don't remember which the standard form is. I'm just looking at the book. It's either general form then is one of them.
Yeah, standard form is not one that I use a lot. Hold on. Let me see if my book lists standard form for a quadratic. Actually, the one I've drawn can't be right because it doesn't have an x squared in it. So, standard form of a quadratic. I got it? 163.
Yeah, I just got it too. Oh, it's a x minus 8 squared plus k.
That's vertex format. Okay.
Oh, that is?
That's the vertex format. I didn't realize that that was called standard format. Yeah. In other words, y equals a times x minus h squared plus k. And this is the one I was going to...
is the vertex.
Exactly. In other words, that won't actually allow you to plot it immediately, but it will give you the vertex, which is a good starting point. You'd still probably have to go back... Yeah, let's do that. Let's put it in.
How do you complete the square and stuff?
Okay, so first of all, a is 1. So let's work with this part. Haven't changed it yet. So what I'm trying to do is complete the square of the inside so that I can represent it this way. Okay? Now, the first step for completing the square is to make sure your coefficient is 1. And it is, so we don't have to factor anything out. If I had a 2 here, I'd have to factor that 2 out, and a would become 2. But in this case, it's 1, so all I have to do is complete the square. Do you remember how to complete the square? Take the coefficient of the x term, divide it in half, and square it.
Coefficient. So 1 divided by 2 is a half, squared is a fourth.
And since I've added a fourth, I have to subtract a fourth to balance things out from the same side of the equation. Normally when you're working with these, sometimes you'll add something to the left and you have to add the same thing to the right. Well, it's okay to add something to the right as long as you subtract it from the right also. So me adding this 1/4 and subtracting 1/4, I have not changed the equation. But now I'm able to write this in the way I want, which is x minus 1/4 squared. And then minus 6 1/4. So now I have it in standard format where we know the vertex is the positive h, because remember the standard format is x minus h. So the x-coordinate of the vertex is 1/2. The y-coordinate of the vertex is negative 6 1/4, which we got doing it the other way. Problem is that now we're really not done, because in order for us to graph this, well, we know the vertex is down here, but we don't really know how skinny or fat it is. So either I need a y-intercept or I need the zeros. And figuring out the zeros is actually much easier going back to doing that. So all I had to do is factor that to come up with the zeros. So I know my zeros are at 3 and minus 2, whether I have to do it again or not. And now I can draw my parabola. You only need 3 points to draw a parabola. So actually, once I got the vertex using the second method, it would have been legitimate to find the y-axis intercept, which is really easy to find because you just make x 0. So if I make x 0, I have 1/4 fourth minus 6 1/4, so the y-intercept is at minus 6. Well, there's 1 point, there's 2 points. We know everything is symmetrical, so that point. So that's another way to graph the thing without finding the x-intercepts. Just find 3 points. 3 points define a parabola.
Yeah.
But
All right.
your teacher may want you to find the x-intercepts always in order to graph it.
All right. Well, next question then.
Okay.
Find the maximum or minimum value of the quadratic function g of x equals 2x squared plus 6x plus 3.
Where's the maximum or minimum going to occur?
No idea.
What is this? This is a parabola? Could look
Yeah.
like that. It could look like this. It could look like that. Where's the
Well,
maximum?
the maxes would be at infinity.
Right. So we're really looking for the minimum because we know it opens up. So where's that minimum going to occur?
Somewhere
If this is my, where's my minimum occur there?
at the bottom.
At the vertex.
Yeah.
So all we need is the vertex and we'll have the minimum. So let's get the vertex x coordinate.
Okay.
What is it?
So negative 6 over 2a
So that's
equals...
Oops, excuse me, I didn't write it correctly. I was reading what you were.
Yeah, negative 6 over 4.
So that's the x coordinate. But their question is, what is the minimum or maximum, which is really saying, what is the y value there? So I need the y value of that vertex also.
How'd you get negative 3 halves, though?
Minus 6 over 4 reduces to 3.
Yeah, okay. My bad.
Okay, so now we need the y-coordinate, and this will actually be our answer. Whatever this comes up to be is going to be the minimum value of this function. So we really need g of minus 3 halves. So let's plug in minus 3 halves and see what we have.
I got negative 1.5.
Let's see, that's 4.5. This is minus 9 plus 3. So that is the minimum value. In fact, if we had to plot this based just on the vertex, we'd go minus 3 halves, minus 3 halves. There's the vertex. That's what that thing looks like. And I haven't drawn it accurately. In other words, I don't know that that's the intercepts, but I don't care. The only thing they want is the minimum. That's that value right there. That's minus 1.5.
All right.
Okay.
So this one says, a cannonball fired out to sea from a shore battery follows a parabolic trajectory given by the graph of the equation h of x equals 10x minus 0.01 x squared. 0.01 squared. X squared, sorry, yeah. Where h of x is the height above the water when it has traveled a horizontal distance of x feet. For A, what is the max height that the cannonball reaches?
Okay, did I get this equation right? Is it 10x minus 0.01 x squared?
Yeah.
And that's it?
Yeah.
Okay. So that's a quadratic. Which way does it open?
Down.
Right. And we know that a cannonball is going to follow this kind of path anyway.
Mm-hmm.
Okay. So, I'm sorry again, what was the question that they're looking for?
What is the maximum height that the cannonball reaches?
Okay. That's it?
Well, that's part A, and then
Part
B is how far before hitting the water.
right there. Okay.
Yeah.
So the maximum height is once again going to be what?
The vertex.
Okay. But in order to get it, we got to find the vertex x-coordinate and then the vertex y-coordinate. And the vertex y-coordinate is our answer. So what's the x-coordinate?
So, negative 10 over 2 times negative 0.01.
Be a negative 0.02.
So, I got 500.
Okay, that's correct.
Okay.
So that's the height.
So 500. So we plug that in.
No.
No?
No, that's just the vertex. So that's the height. That's the y-coordinate. That's h of x right there when the cannonball hits its height. In order to figure out how far it travels, we need to figure out the coordinates, the intercepts. Right? In other words, obviously when x is 0, the height is 0. So let me redraw this a little prettier so that it makes a little more sense. Cannonball fired right there, comes down right there. We know this is 500 feet.
Yeah.
Because that's the vertex.
So you just need to find the zeros.
Yeah. So we know 1, 0. We can look at this and see that when x is 0, that point is 1, 0. So the question is, what is that point? So what do we have to substitute for h of x in order to solve this? X is 0 in 2 places. It's 0 right there, and it's 0 right there. So if we can solve this equation right there, we'll find out the x value, the second one that makes it 0. Well, how do I solve this?
Maybe factor out an x.
Quadratic, but it's an easy quadratic to solve because there's no constant. So we can factor out an x.
Yeah. So then...
So if that's equals 0, there's 2 solutions. X equals 0 is one solution. We already knew that because we knew that before anything happened it was at 0 and the height was 0. So an x here is actually time. Okay, so the other thing is 10 minus 0.01x has to equal 0.
So that x equals 1,000 then.
Right.
Alright. Good. Alright. Graph the polynomial showing clearly all x and y intercepts.
Okay.
Negative x plus 2 cubed plus 27.
Like that?
Yeah.
Or is the negative sign being cubed also? Just like I wrote it?
Yeah, just like you wrote it.
So we want to graph this, and we want to show all x and y intercepts. Okay. First of all, do you know how to graph y equals x cubed?
Yeah.
That looks
It
like,
likes,
let me draw
yeah.
this in a dotted line here. So that's something like that. And if we look at this, we can see, well, what do we have going on here? We have a reflection about which axis, this negative sign?
The X.
Okay. And we have a horizontal translation of which direction and how much?
2.
Okay. And then we have a vertical shift
Up 27.
of up 27. Okay, so it's always a good idea to do your reflections first, not last.
Mm-hmm.
Okay, because it can matter. So the first thing I'm going to do is that.
Mm-hmm.
So this, let me just label that, is y equals minus x cubed. And then I'm going to move it 2 units to the left. So that goes through minus 2 and not the origin. And then I'm going to shift it up 27. So this point, minus 2, comma 27, is on my curve.
Mm-hmm.
So
Alright, that makes sense.
Like that. That's the way to draw it. Now let's see if we can figure out all of the x and y intercepts. Okay, well the y-intercept's pretty easy. What is it?
0.
No. Remember your y-intercept is where
27.
x is equal to 0, and your x-intercept is where y is equal to 0.
27.
Well, plug in 0 for x and do this math.
2 cubed is 8. Negative 8 plus 27. 19.
19. So we know it crosses the y-axis at 19. Where does it cross the x-axis?
Negative 2.
Well, let's see. We need to solve this for, put 0 in for y, and then solve this equation. Move the 27 over, get minus 27. Now what's the next step in trying to solve this equation?
Would you cube root it or divide it by negative 1?
I'd divide it by negative 1. Let's just get rid of both negative signs. Now what?
Cube root.
Okay, cube root of 27 is 3. Cube root of this is x plus 2. Therefore, x is equal to 1. So there is the x-intercept. So that is 1 comma 0. This is 0 comma 19. And we know the curve looks like this. So that's a pretty good approximation of it. And you think about this for one moment, whether I've drawn this correctly. Thing I don't like about the way I've drawn this. Yeah, I haven't drawn this correctly. Notice that there was one more key point. What was the other key point of this cubic? The key point is, in other words, if you're drawing a cubic, it's that inflection point right there. That inflection point went through the origin with y equals x cubed. And I know this inflection point has moved 2 units left and 27 units up. So somewhere up there is my inflection point. Let's
Negative
label
2
that.
comma 27.
Yeah. And now, if I really want to draw the graph a little more accurately, I have my two intercepts, and I know my inflection point. So I know that it has to look something more like this. There's my inflection point.
Yeah.
So more like that. I suck at drawing, but there are three key points on a cubic function, and that's the intercepts and the inflection point. So as long as we have the 3 points defined, we're okay.
Right. Alright, so the next one. Use synthetic division to find the quotient in remainder when x, so it's x to the 4 minus 4x squared plus 2x plus 5. Actually, skip that. I know how to synthetically and polynomially divide.
Okay, did they give you the solution to what to divide this by?
Oh yeah, x minus 2. But I think I can actually do these ones.
Okay, but x minus 2 means that goes there.
Yeah, positive 2.
In other words, the solution would be x equals 2, and you put your solution in the box there.
Yeah.
And you use just the coefficients, and then you drop it down. So that would give you the remainder if I divided x minus 2 into this polynomial. Whatever this final thing ends up being is your remainder.
Alright,
I
so...
can go through that if you want, but there's another key thing here is you need a dummy variable. You know, this one might be worth looking at just briefly because it's unusual. Because it's missing the x cubed term. So if I'm going to do synthetic division here, across the top is going to be 1. I'm going to put a dummy 0 for the x cubed, minus 4 for the x squared, 2 for the x, 5 for the constant. I'm going to divide it by 2 and proceed from there. So I'll just do this real quick. Drop down the 1, multiply, add, multiply, add again, multiply, add, there's your remainder. Here is your answer. So the answer would be x cubed plus 2x, plus 2x squared, no x term, plus 2 with a remainder of 9 divided by x minus 2. So there is your answer to that question.
Yeah.
But notice that it's real tricky. If you don't put in that dummy variable, you're not going to get it right. Okay. What next?
This says, perform the indicated operation and write the result in the form a plus bi.
Okay.
I is an imaginary. So the first one is in parentheses 3 minus 2i plus in parentheses 4 plus 3i.
These are very straightforward. Add the real part, add the imaginary part. What's the answer?
I don't know. You just boil it or you just add it?
Add the real parts, so 7.
7 plus I.
Okay.
Okay.
So adding and subtraction is very straightforward.
Alright, so then this one then. It's the same thing. It was the same thing, but with no addition sign. It was multiplied. Can I just FOIL it out?
Yeah, give them to me again.
3 minus 2i and 4 plus 3i.
FOIL it out, or as my new favorite expression, multiply everything by everything. Because FOILing works great if it's a binomial times a binomial, but if you put a binomial times a trinomial, FOIL doesn't work at all. But multiplying everything by everything does. So go ahead and FOIL this.
Mhm.
I'll write as you give me the terms.
3 times 4 is 12 plus 9i minus 8i plus 6i squared. No, minus 6i squared, sorry.
Okay.
So it'd be
I squared is what?
negative 1.
Okay.
12 minus I
Plus
plus
I,
6.
because we got a plus 9 and
Yeah,
a minus 8,
and then plus 6.
which is in A plus BI format. What is that?
Yeah, 18 plus I.
All right.
All
So
right.
multiplying is very straightforward. The only
Yeah.
one that's not straightforward is division. So tell me that they're going to give you the same problem and divide by 4 plus 3i.
Yeah.
Really?
Yeah. They have a subtraction and addition and divide.
I'm laughing because I'm not sure I've ever seen them use the same two to teach all 4 principles.
Yeah.
That's funny. Okay. Dividing by an imaginary number, I suppose we could do this long division, but that's not the best way to do it. There's a little trick here called multiplying by the conjugate.
Yeah.
What's the conjugate?
4 minus 3i over 4 minus 3i.
Right. In other words, 4 minus 3i is the conjugate. I have to multiply it by 4 minus 3i over 4 minus 3i because you can only multiply a fraction by 1 without changing its value. So I can do this without changing the value of this. And the beauty of multiplying the denominator by the conjugate is you're going to get rid of the I. In other words, the only thing wrong with this expression is it has an imaginary number in the denominator, which you can't have. It's kind of like having a radical. You would never leave this as an answer. You would rationalize it and turn it into square root of 3 over 3. Well, same principle holds with imaginary numbers, is you realify it. Okay? So what was that top? 18 minus I, if I remember right? Or was it 18 plus I? It was 18 plus I. Because we had minus 8i and plus 9i. No.
Yeah.
This was a plus, wasn't it?
Yeah.
Oh, yeah. But this time, so I can't do that. I have to multiply it outright. It's not the same as it was before.
Yeah. So it'd be 12 minus 9i minus 8i. So it'd be negative 17i.
Plus 6.
Yeah.
So this is what the numerator becomes when you multiply these two together. And the denominator is going to turn into a number. Notice that whenever you have difference of squares factored, you end up with a first term and a last term. So the first term 16, the last term is going to be minus 9i squared plus 9. So now this turns into 18 minus 17i all over 25. Still not in A plus BI format. So
why is it 18?
Because we had 3 times 4, which was 12, and then we had a plus 6i squared.
Oh, yeah. Okay.
But you're right. Plus 6i squared is minus 6. It isn't 18. It's 6.
Okay. So 6 minus 17.
6 minus 17i. Which turns into 6 over 25, which is 6 over 25, minus 17 over 25i. In other words, that is that format.
Okay. Yeah, that makes sense now.
So those are the 4 processes you can really do with imaginary numbers. And the only one that's tough at all is the division. Because it's not really division you're doing, it's realifying the denominator.
Mm-hmm.
All right.
They have another one too. It's I to the power of 48.
Okay.
Yeah.
Let's go through this. This is always a question. What's I cubed equal?
I'm going to guess 1.
If I squared is minus 1, I cubed has to be minus 1 times I. So minus I. I to the 4th is I squared times I squared, which is 1. Then it repeats. So it repeats every 4th one.
Okay, so it's the pattern.
So that's what you have to do when they say, what is I to the 200th power? So you have to figure out where it is on this pattern. So if this is 1, I to the 8th is 1, I to the 12th is 1. In other words, any multiple of 4 is equal to 1. So what's I to the 48th?
1.
What's I to the 51st?
50 negative I?
Uh-huh.
Possibly? Yeah, okay.
That's all there is to handling those problems, is figure out what multiple of 4 it is, knowing that I to the 4th is 1.
Alright, so we have this last one.
Uh-huh.
Now, I think I may be able to get it, but it's in parentheses root 2 minus negative root 2. Minus, and then the negative root 2, it's negative 2 on the inside of the root. So, yeah, like an imaginary number.
Okay.
And then root 8 plus another negative root 2.
Is this times or something? Is this multiplication?
Yeah, sorry. So, and that one. And then, yeah, new. Root 8 plus negative root 2.
Okay. So if we wanted to, we could change these to A plus BI formats and do the same thing we just did. Okay? But we don't have to yet. Let's leave it in this format and FOIL it. It's the first term.
Well, would we convert the negative 2's to i's yet, or?
Not yet, because that may be a wasted step. They may disappear. Who knows?
So I guess, would it be root 2, root 8 then?
Okay, which is?
Or root 16?
Which is?
4?
Okay.
Root 2 negative root 2?
Let's see. What are we doing next?
4.
We're doing this one?
Yeah.
Yeah, the outside ones. So that is plus root 2 negative that. And then we do the inside, and we have minus root 8 times negative 2. And then the outside is what? Or the last?
Plus 2?
Yeah, because it's the negative times the plus, so it's a minus 2, which gives us plus 2.
Yeah.
So now, if we combine, we have 6 plus, and we can factor out a root 2, being left with root 2 minus root 8. You see what I did there?
Yeah.
Okay. Now, if we want to turn it into A plus BI format, well, we have 6 plus, this is B, square root of 2 minus square root of 8, and this is not I, but square root of 2I. In other words, instead of writing square root of 2, I'm going to write it like this. Instead of writing square root of minus 2, I'm going to write it square root of minus 1 times square root of 2.
Why?
Well, just because it makes it easier to get into I notation. In other words, at this point, we're ready to use I because we know I is square root of negative 1. So now what we have is I'm going to pull the square root of 2 and leave I. Okay?
Okay. That makes sense, yeah.
Now I can distribute this. So I've got 6. Well, that's square root, that's 2. And if I distribute it to there, it's minus 4I. So the final answer is 6 minus 2I. Now, would it have been easier if I had converted it to I to begin with? Perhaps, maybe.
All right, I actually have to get running off to class now, David.
Okay, that's fine.
So thanks a lot for helping
Sure,
today. This is gonna help.
sure. And then we're doing Sunday morning at 11 still?
Yep.
Talk to this time I will just text you the meeting ID. I won't call.
All right, yeah, 'cause now I remember.
And you have that icon on your desktop now, so you don't have to go to that website. You just double-click the icon, and it asks you for a meeting ID.
Yep. And what is the? Did my mom pay you already? Or
Paid you for this session. Yeah, I'll send her another invoice for Sunday.
All right, thank you.
You're welcome. Talk to you later, Mike.
Yeah, bye.
Bye-bye.